I'll go visit this.
Oh, I'll get that. I'll get that.
Is he coach though? I mean, at least I.
Going nowhere else. Okay.
This chair looks like actually blind, so this is like perfect.
Okay.
I know exactly.
You in there.
Oh.
She might be. Oh, okay. Well, can you build it? Is that cool? I don't want to block her, so I'll just go.
Can I block me?
How's that?
Could be. Whoever's sitting there, that's going to be.
I'll just.
Hating life.
And Danielle's was the restaurant.
Oh, okay.
Or I could set it over here.
And there's room over there, so you may want to swing around the other side. This seat's all right, right? Put that on the other side there. Yeah.
Who wants the furniture?
I have to go to the restroom.
Oh, yeah.
Better go
Yeah.
while there's a little bit of space now.
Yeah,
Up
good point.
halfway.
Yeah. All right, let's see. All right, maybe this will work. Maybe. Did you swing here? Is that right?
This chair is going to break.
Oh, really?
Yeah.
Yeah, I knew one of them wasn't doing too well. Is that one right? All right, this is the one that's.
Okay, cool.
All right, cool. Thanks. Wow. I know the first day is normally freaky. This is the freakiest first day yet. So I'm going to go really quickly over a couple things, so you guys have most of the time to work together on first little in-class assignment. Let me just see what you guys remember. Oh, what have I got now? Cool. All right, here we go. So if I had something like, yeah, now you guys get used to my terrible writing. If I had something like that, right? Now hopefully first thing you guys realize is if I said simplify this, what would your answer be?
Yeah,
It's already simplified, right? There's no like terms. Cool? Just want to start everybody off on the right. I can't say this is suddenly negative 4a cubed y. I'm not multiplying. I can't put anything together. Cool. All right, so that's the real basics. Now here's the second level is basic stuff. If I then said if a is negative 2, y is 5, and b is negative 3, now you could tell me what that is, right? I could say evaluate this expression. So do that. I don't know if you could see anything over there. Let's see this better. Figure out a good place to put this. Alright guys, how are we doing there? So, first thing is, a lot of people put this in like this, which messes them up right in the beginning. Because I don't know how many guys maybe thought this is negative 4. The very first thing?
It's positive.
I got to square A, so I got to square the whole thing. So in general, when you plug stuff in, you should plug it in parentheses to maintain whatever's going on. Right? So minus 4 times A against negative 2 times Y, which is 5. Plus b cubed, and b is negative 3. So this should be positive 4 there, right? Okay. Good. So in the middle here, I get plus 8 times 5, so plus 40.
Minus 27.
I love it. Negative 3 cubed, I got to multiply negative 3 3 times. And of course, then the negative stays alive, right? 2 negatives cancel, 1 stays alive. So you get 44 minus 27. 17, cool. Yeah.
Could you have done parentheses minus 2 times minus 5 and still come out with the same answer?
Say again? I'm sorry.
Could you have done minus 2 times minus 5 without the double parenthesis, the double bracket? See how you have a bracket around each of the numbers? Could you have
Oh, sure. Yeah. I really
Yeah.
just need the 1.
Yeah.
But whenever I just normally,
Okay.
without even thinking, I just put them all in parentheses. So even if I have extra, I still maintain the operation. Do you see what I'm saying? So that's what the mistake people make when they just plug it in without parentheses. They don't maintain the operation. Now I'm squaring a piece of A, not all of A. Yeah, so I just blindly put them all in there. I do have more than I need, but I've got as much as I need.
Well, I understand what
Cool.
you're saying.
But there's other ways to do almost everything I do in here. Right? So I do try to show, and this one is not even a major thing, but like factoring, solving certain types of equations. There are other ways to do it than what I'm going to show on the board. As long as I can follow what you're doing and it's legal, I'm okay with it. Right? So if you're shown a different way, you can tell me, or you can just do it that way. Right? You don't have to do it the way I show you. The one exception to that rule that's happened recently, has any of you ever heard of bottoms-up method of factoring? Good. Keep it that way. Right?
Okay.
It's a cheap way to do it. People can do it. The numbers pop up out of nowhere, but I only let you do it if you explain to me why the math works. And I haven't had anybody be able to do that yet. So it hides the math, which isn't what we need here. We need the math right there so we get used to it. Right? So bottoms-up method, stay away from that. You cannot. It's the one time I've ever said you can't do it a certain way. Okay, so that's just to get us started. And today I'm going to kind of stay here for right now. I've got to figure out a better place. I haven't taught in this room in forever. I maybe don't want to cover that. But I got to figure out a better place for my camera. I'm just going to do some quick things anyway. So I'm just going to stay right here. What are the natural numbers versus whole numbers? Anybody remember those? Integers, rationals. Any of these words sound familiar?
Whole numbers. They sound naturals is like fractions of positive.
Careful now. Natural numbers are what came to us naturally. So you can imagine cavemen, I got 1 rock, 2 rock, right, or whatever. So natural numbers are what came to us naturally. I can see my fingers, 1, 2, 3, 4, 5, right? So natural numbers are also called the counting numbers. So that's the natural numbers. And just everybody understand what that little brackets mean?
And they're all positive numbers.
Yeah, they're all positive, exactly. So the natural numbers start at 1 and increase by
Cut
1.
off a finger and he said, oh, minus 1.
So, does everybody understand what those brackets mean?
Yes.
Right, that's a set of those numbers, and the little ellipses here, the little 3 dots mean continue as I show, right, continue to see, okay. Whole numbers adds the idea of 0, right? And entire civilizations did not have a concept of 0. They had a concept, but they didn't have a symbol for it. They didn't have a way to work with it. The Babylonians had no symbol for 0 until very close to before the civilization fell. They did develop the idea, but then they were like, oh crap, that's it for us. So the Babylonians, when they're trying to write, 407, no, they used, that was their 10s and this was their 1s, which is neat. Don't worry about that. But when they're trying to write 47, they didn't have any 0. They'd have to keep space in there, but then somebody might say, well, that's 47. They just, what? So they need 407 chairs and they only give me 47. Oh crap. I'm going to die because Babylonians out of the more immediate with their punishment. But whole numbers adds the idea of 0. Right, so that's 0, 1, 2. What do integers add the idea of? Negative. So a little story I like is my little caveman, he's got this 1 rock. He loses it, and now he's got no rocks. So he's got to borrow a rock, so now he's in debt. So he's come up with the idea of negative, right? So I can go about -3, -2, -1, 0, 1, da da da. Okay, and that's basically all the numbers we normally write on like a number line. But what about all the numbers in between? What are the rationals? Anything that could be written as a fraction. Cool. Let me see if I can spell. I don't know. Is it expressible as a fraction?
Most people would not be rational.
So this doesn't necessarily have any direct connection to the word rational as we use it in the English language. But rational numbers, for example, obviously 1/4 is rational. Maybe not so obviously, 3 is rational. Because I can put 3 over 1. Any number that can be expressed as a fraction. What's another thing that's obviously rational?
Decimals.
Decimals. Certain types of decimals, like 0.7, because 0.7 is also known as 7/10. Anything that can be written as a ratio of whole numbers where the bottom is not 0. Right? And then also the thing is, something like this, 0.111111 forever. Believe it or not, that is rational. All right, let me see if I can take you with me here for a second. How are we doing so far? I mean, this should definitely be very basic. What I'm about to show you might never have seen before, but it's really interesting. At least for me. I don't know. We'll see if you guys like it. You guys might have never seen this before. I don't know. But what is 0.1111 repeating? I don't know. So I'm going to call it x. Right? I'm allowed to do that. It's freaking algebra. I don't know what the hell it is. That's the great thing about algebra. What we really do is, if we don't know it, we just call it something so that we can put it places before we even know what the hell it is.
And then you just put a little one.
So now here's the cool thing. The problem with this number is it goes forever, right? Is everybody cool with the little line over the one, right? We all know that means it goes forever. If I multiply both sides by 10, what happens on this side? If I multiply by 10? Moves the decimal over once, right? So now it's this. If I subtract these, 10x minus x is 9x. Cool? 1.1 forever minus 0.1 forever is 1. So x is 1/9. If you did 1 divided by 9 in your calculator, it would be 0.1111. Why does this make sense? If 1/9 is 0.1111, what's 2/9? 0.2. What's 3/9? And what's 3/9 if you reduce it? Reduce 3/9? 1/3. How many of you guys know 1/3 is 0.3333 forever? Some of you guys know that. There, I just proved it a different way. Crazy. So you can do this with anything that repeats. If it was 0.272727, I have to multiply by 100 to make the decimal move twice so that the forever piece would match up again. Do you guys see what I'm saying? So normally things over 9 or 99 or over 33 or something like that, they're normally those repeating decimals. How are we doing so far? So repeating decimals, anything that has a repeating type pattern to it can be written as a fraction. So repeating decimals. What's left then? What's the trash pile? These all kind of build on themselves, right? Every one of these is in here. Every one of these is in here, and so forth. What's the trash pile? What's the weird shit?
Irrationals.
Irrationals. Who's got an example of an irrational number? Pi. All right, that's a good place to start.
Any number I don't understand.
Say again?
Any number I don't understand.
Oh, man.
Non-repeating decimal.
Yeah, so pi, that's why pi gets a good point. Any non-repeating decimal, anything that doesn't stop and doesn't have a pattern to it. Because if it stops, I just put it over 1 with that many zeros, right? If it stops, it's great. If it doesn't stop and doesn't have a pattern like pi doesn't, that's irrational. What about square root of 7? That's irrational, right? Any square root that I can't do is going to be irrational. We'll learn some new ones this semester too. We'll learn another one that's got a letter for it. Yeah.
That would go for any root that you can't do.
Any root that I can't do. Exactly.
Cool.
Of course, roots of negative numbers are even worse. All of these are real numbers. And of course, this semester we're going to talk about the numbers that don't go in this group, the non-real numbers, which is where you go, okay, this is where you math people are just, what the freak are you doing, right? Have you guys talked about complex numbers yet? Complex, no? Some of you guys know a little bit. Imaginary numbers is another horrible name for it, because students kind of go, Oh crap! Now you're just making shit. I knew you were making shit up. Now you're being honest about it. No. All right. So how are we doing so far? I mean, that's very basic stuff. The things that we use a lot are natural numbers because of the fact that it counts things for us. We use those a lot. But I mean, these other words might come up every now and again. Okay. Oh God, this is terrible.
Yeah, I'm glad you put it right. I didn't even give you a eraser.
Yeah, we spare every expense. Because we have no money to cover it. All right, a couple little other things real quick, and then I'll let you guys get into it. Remind me, where'd it go? Oh, what about this here? This is some of our favorite type of problem here. What? Dude, if you wanted to, I think you could sit over there, and there's a little writing surface there. You see what I'm talking about? You can maybe see the board better then. What do you have to use here? What do you actually have to use no matter what? PEMDAS is always in effect. What the hell is PEMDAS?
Parentheses.
And I hate it when we write it like this, because that makes us think that M comes before D, which it doesn't. It does here because it's easier to say than this. How do you say this? PEDMASA. That's easier to say. That's why we did it. Roughly. Right? But multiplication division as it comes, not multiplication before division. So I hate writing like that. I like to write like this. Definitely parentheses. Whatever's in parentheses, you got to do it first. Then exponents. Then either one of these as it comes, and then either one of these as it comes. Right? It's not multiplication before division. It's whichever one's first. Right? So in this case, can anybody tell me what I would do last? What's the very last thing I'm going to do? That's the very first thing I'm going to do, right? The very last thing I'm going to do, no. Division comes before these. I'm going to subtract a 7 and do 4 minus whatever that number is. That's the 4 and that 7. Those are the last things I'm going to do. Because they are subtraction. And that's way the freaking hell down there. Now, why is that subtraction the first thing I'm going to do? Because it's in parentheses. Cool. So the very first thing I'll do is that. And what is that?
Negative.
Now, the biggest mistake I see is people say right there, they said 6. Now, let me show you on the side here why that's not good. What is 4 being divided by?
2.
Okay, if you do this, isn't 4 being divided by 2? Now, if you make that, now what's 4 being divided by?
14.
So you made it a different problem. Don't make it a different problem. For one thing, it sucks now. 4 can't be divided by 14 evenly. You have to like make a fraction and all that kind of crap. Screw that. 4 divided by 2 is 2 times 7, 14. So why make it harder than it is? So here, don't make that 6. Whatever this number is, I'm going to divide it by 3. Not by 6.
Yeah.
Right? You guys see, that's why it works that way. I've got to pick a way to do it so we all come out with the same answer. If we all can come out with whatever answer you want, math is unnecessary. Chaos rules. Some of you guys might want that, but oh well. Yeah.
I learned this before. I was always told, like, if you have a confusion about that, just do what you did earlier. Put the parentheses in, like, bracket off what's going to be done in the operation.
So the very beginning. So you
the
focus.
very beginning, so you can't go, oops, oh crap, did I do that wrong?
Because a lot of times your brain will hijack you, right? You got to stop your brain, which is hard to do because your brain is you. But you got to stop your brain. You know, no, it's not 6. Stop. Right? I totally understand it, and it's really easy mistakes to make. PEMDAS are the most easiest mistakes to make, because their brain just says, that's freaking 6. No, it's not. So what's the very next thing I can do here? Exponents, I love it, right? And there's nothing else in parentheses to do, so do the exponents. All right. Now here, this whole little inside piece has got multiplication and division. That's the next thing I do, right? As it comes. 3 times 9 is
27.
divided by 3. Oh, I see what you guys. But there's the minus. Cool. So 3 times 9 is 27.
27.
Do this step by step. Divided by 3 times 2 by 7. So 27 divided by 3, 9. 9 times 2, 18. And now everything's subtraction, right? So now I can just subtract as I go. 4 minus 18 is...
Minus 21.
Okay, good. So minus 14 minus 7 is minus 21. I love it. Now, there might need to be some cobweb shaken off in the brain, but that problem right there should not have given you too many qualms, right? If you survive Math 90, which is a 5-credit course, it's a pretty intense course actually, or if you placed into here, this should not give you too many troubles. It's an easy place to make a brain fart type thing, but you should know how PEMDAS works. Brain farts you can't really control, but understanding the concept is what's important. Okay, and then one last thing here before I let you guys jump into this. What was it now? I forgot. Shoot. No. Well, maybe I'll just let you guys jump into it. Yeah, why not? Here we go. All right. So if you have the book, let me see, is this the one? Shoot. So on page 96, and again, it's because the chapter 1 is a review section. Page 96, and it's actually number 11 through 74. Page 96, 11 through 74.
We turn that into, right?
Yeah.
Okay.
So what I want you to do is, I do have copies, but like I said, the copies are hit and miss, and that's, I'm sorry about that, but it's just the way I got it. If you do not have a book, you might want to cozy up somebody that has a book, right?
We're doing these now?
Yes, we are. I do have copies of them.
I already did that.
You already did them?
I thought you said to do it before class.
No, I didn't, but I appreciate that. If you want to, you could do, if you get the book, you can do the chapter test. That's actually the first homework assignment. Yeah. Let me give you these. Who doesn't have a book, who wants a copy of this? All right. Holy crap. All right, wait a minute. I thought more than that. I had the book. Again. All right, do it again. Who needs it? 1, 2, 3. You need it. And you can 1, 2, 3, 4. 4. 1, 2, 3.
You weren't kidding. This hit or miss.
Hey, Jeff,
1. Sorry, what's up?
is there a particular paper you want this done on?
No. Yeah. 1, 2, 3.
Some teachers want big grades on the math thing.
You need one? 11 through 74. Can't remember why it's, oh yeah, that's right.
Do we get to?
Yeah.
So in other words, just a few problems.
Yeah, just a few.
You have them covered back there? In the red hat? Yeah.
I can't.
You good? Okay. So if you want to work together, if you want to bounce ideas off of somebody sitting near you, if you don't know anybody and you see somebody who looks like they know what the hell they're doing, you can go cozy up. If you want to do it on your own, awesome. Can't quite read them, get a book.
Tonight I'll have
All right. I'm going to go, as you get started into that, I'm going to go print out copies of the homework sheet. So you guys can start a homework as soon as you get a book. And I'll be back in a minute.
What I got it.
I stood up saying what it's
Now, what's 5y y 7 zx. وأصلا الطاقة مش معنى تجاوز. يعني zx مو 7z.
11. Is it 11? It's 11. So if you figure that out. It's the same with that.
Yeah, no, everything.
all the numbers aren't shown.
Yeah, no, everything in the red let you know where in the chapter you can find it. That's all.
Change teachers.
Aber